Good morning. Thank you for having us today for this presentation that we have called Stream Processing with Apache Flink in Zalando's World of Microservices. I know there are a lot of buzzwords in that title, but we will try to cover all of them in this presentation. So the agenda for this presentation is, first we will introduce our architecture at Zalando, our microservices architecture. Then we will introduce our team and our architecture to do data integration and distribution at scale in the cloud. Then we will describe how we use Flink in a microservices world. Afterwards, we will explain a couple of use cases that we are working on with Flink, which are business process monitoring and continuous ETL. And finally, some ideas that we would like to share with you about the things that we are going to do in the future with Flink and stream processing. So who are we? Mihail and Javier, we are big data engineers at Zalando. And, well, who is Zalando, or what do we do at Zalando? We are basically a fashion retailer. This is our front end, our web page. We also have mobile applications. You probably don't know us here in the US, but we are pretty big in Europe. Basically, we are in 15 countries in Europe, all over Europe, I would say. We have more or less 19 million active users. Last year, the revenue was more or less 3 billion euros. We have 1,500 brands, more than 150,000 products, and we have more than 11,000 employees in Europe. From these 11,000 employees, we are more than 1,500 engineers at Zalando. Our main office, technology offices, are in Berlin, but as well we have offices in Dublin and Helsinki. And if you would like to know more about our company, our tech culture, we are happy to invite you to go to tech.zalando.com to learn a bit more about us. So before start talking about Flink and stream processing at Zalando and inside the business intelligence team, I would like to introduce what we were doing for the last 6 years at Zalando and inside the business intelligence team. So the architecture, if you have experience with business intelligence, the architecture of any business intelligence team is more or less like as follows. So you have your application, which contains the business logic. They write all the data and they update all the data in some relational databases, such as the CRM, the CMS, the ERP. And then you have some classical ETL process that extracts data from these databases, applies some transformations, and loads the data inside a relational data warehouse. We have kind of the same architecture at Zalando. Our data sources were basically Postgres databases. We used Pentaho Kettle to extract the data, to transform the data, and to load the data into our transactional Oracle data warehouse. From this data warehouse, we export the data to Exasol, which is an analytics database that is used by data scientists to create models and do all their magic. And as well, several tools like MicroStrategy connect to our Oracle data warehouse and in order to create reports and for our stakeholders to visualize the information. That worked for most of the time, but last year, the company changed the architecture, the play rules, and we introduced something called radical agility. Radical agility is our new tech culture and is driven by 3 pillars: autonomy, mastery, and purpose. Yes, autonomy is the urge to direct our lives. Mastery is the desire to get better and better at things that matter to us. And purpose is the yearning to do what we do in the service of something greater. Yes? I would like just to explain a bit the concept of autonomy inside technology in our own implementation. As you might remember, yesterday's first keynote, we discussed a lot about autonomy. So I would like to show you how we do autonomy inside Zalando. So basically, now autonomy means that we can choose any technology we want inside the teams, the autonomous teams. So if you want to build things using Scala, Java, Python, Ruby, any application, you can choose any stack, any technology, any language. And as well, you need to select the persistence layer. Yes, you can use Postgres, MySQL, Oracle, Cassandra, whatever you need. You, as a team, are responsible of your own operations. And as I said, we are autonomous teams, and each team has its own private AWS account. Yes? So we are building everything in Amazon. So how these teams interconnect, how all these applications work, or how do we connect all these microservices? We connect them via RESTful APIs, right? These RESTful APIs are connected via the public internet, and the databases are hidden behind the microservice and inside the Amazon cloud. In this case, as you remember from the business intelligence architecture, we need to connect to the database to start information. But in this architecture, a classical ETL is quite complicated to do. So how can we solve this problem? How can we extract data from the databases inside the several microservices and deliver this data to our data warehouse to complete the cycle of business intelligence? For that, we created an event bus that we called Nakadi. And basically, Nakadi is a Kafka surrounded by RESTful APIs, yes? Encapsulated inside a RESTful API. So teams write data to this Kafka event bus, and teams can retrieve data from this Kafka event bus as well, using RESTful APIs. And then from this Kafka, from this event bus, we, at the business intelligence team, extract all the data that we need and deliver it to our data warehouse. So now, how can we do that? How can we extract the data from our event bus? Because we have solved the problem to extracting data from multiple sources. Now we just need to extract it only from one service. And how can we do that? The answer for that is SAIKI, which is our team inside Zalando. And we are in charge of taking all the data from this RESTful API, from this Nakadi event bus, and deliver it to our data warehouse. So how we do that? So we have a bunch of technologies and a bunch of applications to do that for us. The first thing is that we have our own Kafka bus inside our own account in Amazon. We extract the data from Nakadi and we put it in our own Kafka bus, in our own Kafka queue. Then we extract this data from Kafka with a RESTful API that we built by ourselves, and we use this exporter to write the data to S3. And then from S3, we are able to download the data to Oracle and then update and do all the transformations and load inside the Oracle data warehouse. Okay, but now in Kafka, as you may know, you can put everything you want, basically. So before we were having Postgres databases, which are basically tables, and we were loading them into an Oracle table. Now we have JSON payloads. And in JSON, you can put everything. So sometimes we need to manage these complex JSON schemas because, well, Oracle still uses tables. So we need to flatten somehow these JSON objects. For that, we use stream processing with Flink. Yes? So now, for these quite complex JSON payloads, we are able to pre-process them in our own account, then write them back to Kafka, and then export them to Oracle, as I already have explained. As well, our team is building a data lake, which is basically the long-term storage for the whole company. Yes? This data lake is basically using HDFS, Hadoop, Spark, and a lot of technologies upon. But as this talk is more is for stream processing, then I'm not going to dig a bit into the data lake technologies. So now, as well, we are pre-processing data with Flink. We are writing the data to S3 and we are downloading it to our data warehouse. And this allows us not only to deliver data to Oracle, but to basically any team that needs the data. In this case, for example, a forecast team or a data science team. They can connect to our account and download the data they need. So to sum up how the architecture or what have we done at the team until now, basically before we were extracting data from relational databases using delta loads. Now we have data streams, and we use Kafka for that. Before, we were using JDBC connections to our Postgres databases. Now we are using RESTful APIs to connect to these databases, to these new microservices. Before, we were just relying on Postgres databases. Now we can access any database that we want, any kind of database. And before, we were extracting data and delivering it to only one team. Now we are able to deliver it to multiple teams. So this is basically what we have built to fulfill this requirement of delivering the data to the BI teams. But we realized that we have a lot of opportunities to do here. Yes, we have a lot of things that we can do in Amazon in cloud with Flink. And in order to talk about these new opportunities and these new challenges that we face, I would like to invite Mihail to speak about how we use Flink in Zalando.
Thank you, Javier. In the new world of microservices of Zalando. So let's first look at what opportunities do we have for the next generation of business intelligence. First of all, we have cloud computing, so we can do now distributed ETL, and we can also scale easily. We have access to real-time data, as all teams communicate over an Arcadi event bus, and we have the ability to access that data. Then the hub for data teams, the data lake, which provides distributed access. And before materializing the data into the data lake, we can also transform it. So, for instance, aggregations, joins, and so on and so forth. And last but not least, we have semi-structured data, as Javier already mentioned. And in order to process this data, we want to use general-purpose data processing engines like Flink or Spark. So how can we take advantage of all these opportunities? Our first thing which came in mind is stream processing. So we started our evaluation. We wanted to evaluate several candidates for this job. We started with this short list, Spark, Storm, Flink, and Samza. We decided to rule out Storm and Samza because we have a flexibility requirement. We also want the frameworks. We also wanted the framework which we chose to be able to process also data in batch. So we did some POCs for our use cases, and I'd like to present to you the differences between Spark and Flink. So we evaluated Spark 1.5.2 and Flink 0.10.1. Of course, the processing mode, for all of you know, Spark uses microbatching, and Flink processes tuples at a time, one tuple at a time. Regarding the temporal processing support, in Spark, we only had the processing time, while Flink also enables us to use the event time and the ingestion time. The event time is particularly important to reason about events, so we know exactly when those events occurred in a real time. And this thing also enables us to handle out-of-order events. And then the latency, seconds versus sub-seconds. Back pressure handling. In Spark, there's a need for manual configuration, while Flink manages it by itself through its system architecture. And one important feature, very important feature for us was the state. In Spark 1.5.2, the state was implemented as a distributed data set. So a full state scan was required for each microbatch. To be fair, Spark introduced with the version 1.6 key value store, so it has now the same capabilities as Flink had with the version 0.10.1, where only a value lookup by key was necessary. Now let's go to the more subjective features. The operator library, we found it in Flink to be the operator library of Flink to be superior. For instance, we have split, window my count, and so on and so forth. Then there's the support, and we have had very good experience with the mailing list from Flink, and also we had direct contact with data artisans. As I mentioned, we built POCs for our use cases. We also did some benchmarking. And during our evaluation phase, also the results from the Yahoo benchmark came out. And our results were consistent with them. Let's have a look at what Yahoo did. So on the x-axis, you can see the throughput in thousands of events per second. And on the y-axis, the latency. As you can see, the Spark latency increases with increasing throughput, while the latency for Storm and Flink remain low. Having all this in mind, we decided to go with Apache Flink because it's a true stream processing framework. It processes events at a consistently high rate with low latency. It's scalable and has great community and on-site support from Berlin, Europe, where we are also based. Last but not least, we have also access to university graduates with Flink skills, as Flink originates from the Stratosphere Research Project, which was developed from Berlin's academia. And if you would like to find out more about the evaluation, I invite you to have a look at our blog post. Okay, so we went with Flink, and because we use AWS, then we need to build a Flink appliance for it. And we use Flink in standalone mode on EC2 instances on Docker containers. We have a master load balancer, a load balancer for all master nodes, and a load balancer for all worker nodes. The line for the second master is dotted, as this is still work in progress. The second master is for the second master is for the high availability mode of Apache Flink. So if the main master fails, then the other shadow masters can take over. Okay, now let's have a look at the use cases. How do we really use Flink for our purposes? First, let's start with business process monitoring. I would like to introduce now a short definition of what a business process is. So a business process is in its simplest form, chain of correlated events. For instance, you have a start event and you have an end event. If you buy some fashion products from our company, from our website, then an order created event is generated in one microservice in the platform. After all the parcels have been shipped pertaining to that particular order, then all parcels shipped event will be generated. Okay. And having the architecture in mind with the centralized event path, then we can see that all business events which are generated throughout the Zalando platform flow through SAIKI, for our data integration distribution platform. So we have the opportunity to process those in near real time. Okay, so now let's see how what we use, what can we compute having those events in mind, these business processes. So we can check if all the business processes in the Zalando platform work. We can analyze data on the fly, for instance, order velocities, delivery velocities, and control SLAs of correlated events, for instance, to find out when the parcel has been sent out after an order has been placed. Now let's look at the architecture which we designed and are implementing for this use case. So we have the first part, which was already introduced by Javier. Then we have Flink. So we read events from the Kafka Unified log with Flink, process them, and store the results in Elasticsearch. From there, we have a user interface. We have a different visualization component, which is built on using Python and Google Charts. We first started using Kibana, but as our requirements kept growing, we decided to go with a specialized solution from our own. The UI is accessible via public internet, via OAuth from public internet. And we also have a alert service. So if several instances, if several SLAs have been violated, then we can send out emails. So a team from Business Excellence can look into it and assure and check the process and fix things. We also have a configuration service to configure the UI and also Flink, so we don't have to specify from which topics it has to read when it processes events. It just gets the configuration from the Postgres database. Okay. So what features do we use in Business Process Monitoring from Flink? We use, so we have thousands of event types, and each event type has a Kafka topic. Then we analyze the processes with correlated events, and for this we use joins and unions. Then we enrich data based on business rules. And we use sliding windows from 1 minute to 48 hours for platform snapshots. We also use the state to store and modify alert metadata. Okay. And in the future, we'll be working on complex event processing, so we'll need to generate complex events. But I will leave this for the end of the talk. Okay, now let's have a look at our second use case, streaming ETL. Probably most of you know that the traditional extract, transform, load process looks like this. So we use batch processing. It uses batch processing. It has no real time. It uses a lot of different ETL tools and incurs heavy processing on the storage side. Now with radical agility, then we have now data in a semi-structured format. We have data distributed in separate Kafka topics, and we'll also have increased throughput. So we'll have peak times, meaning that the data flow will increase by several factors. We have a certain product called Zalando Lounge, and there are some campaigns which gives the customers the possibility to buy certain fashion products at discounts, for instance, 50%, let's say. And they have a certain time interval when they can buy those products. So Monday, let's say from Monday at 8 a.m. So you can imagine that all those customers would want to have one of those items and will place orders on our platform. And of course, each microservice is a data source. So right now we have also increased number of data sources. The architecture. So we have the operation systems, the Nakadi event paths. then our own unified log, our own Kafka cluster. And from this, we read and do some transformations in Flink, some ETL jobs, and write them back to Kafka, where we extract them using an exporter. We write them to Amazon S3, and from there we import the already pre-processed events into the Oracle data warehouse. For this, we currently use Flink in production for transformation of complex payloads into simple ones. This enables an easier consumption for the Oracle data warehouse. And in the future, we want to combine several topics based on business rules, such as union and join. Then to pre-aggregate the data to improve the performance. Right now, Oracle is a single point of failure. It's a monolithic relational database management system. And as you can imagine, the loads keep increasing, and we need to relinquish some of its resources by doing the processing in a different system, such as Flink. And of course, data cleansing and data validation. Okay. Now let's have a look at our future use cases. So as I mentioned before, we have this use case with a complex event processing. So if you put an order in our shop and buy several items, it's not clear that all those items will be shipped in the same package. So we'll have multiple parcel shipped events per orders, and what we want to do is to generate this all parcels shipped event when all the parcel shipped events have been received by the stream processing system. For this, we'll use a CP library, which is already included in Flink, and also the state. And another use case, which is coming up, is our deployments from other BI teams, which also want to do their own ETL jobs. So we have now several requirements. We need to manage and control the deployments. We need to isolate the data flows so that no two data flows write on the same sync, so that we don't, so that we prevented the jobs from falsifying data. And we need also some kind of resource management to share cluster resources among concurrently running jobs. Last but not least, we are looking into the stream SQL declarative language, and this would significantly decrease the entry barrier for our colleagues in business intelligence. Most of our colleagues are proficient in SQL, but they don't necessarily have a computer science degree or know how to write Java or Scala jobs. So having a declarative language would enable them to use the power of stream processing. And we have also other future topics from other teams, because each team has its own autonomy and can choose its own tech stack. But let's have a look first for real-time analytics. So, for instance, sales monitoring to see exactly what we sell, and then price monitoring to see how the prices evolve, and so on and so forth. And fraud detection for payments, which is currently in the evaluation phase, and customer contact to contact a customer according to a verbal event pattern, which is also in the evaluation phase from that particular team. I would like to conclude this talk with the following. Flink proved to be the right fit for our stream processing use cases, and it enables us to build Zalando's next generation business intelligence. If you'd like to find out more from our data integration and distribution platform, I invite you to visit our tech blog. Thank you for your attendance, and we're happy to answer your questions.
Are you enriching those JSON payloads with Avro or Parquet or Protobuf or something?
No, not yet, not yet.
Yep.
Do you use Flink CEP to actually execute purchase process workflows?
Sorry, I didn't hear you.
Do you use the CEP inside of Flink to execute business process workflows?
No.
Handle workflows?
No.
Can you repeat the question?
He asked if we use the CEP library in Flink to run business workflows, and we don't. We are from the business intelligence team, so we are not able to run any production or transactional processes because we just analyze data. So. Yep.
You know, the batch requirement you talked about, was that the 48-hour sliding window? Was that really the batch requirement?
No, it's more like suppose that they implement a new microservice or something, or they have there are some problems, or I don't know, they have millions of records to process, or we just implement one new requirement, one new metric, or whatever, and we need to pre-process all the data before now, because stream processing is everything about now, about real time. But suppose that you have, I don't know, 6 months of data to pre-process. So we use this batch processing to pre-process these 6 months of data, and then we leave it running for everything that happens from now.
So you're using Flink for the historical process?
As well, yes, because we try to do a historical process for some other things, but Flink is pretty fast to all of these things. So. Yep.
So you mentioned you are combining several topics, right?
Yes.
Join those topics, or like, do you do it in the post-processing ETL or in streams?
In Flink, we are combining them in Flink. It depends on the requirement, actually. So we are joining them in Flink, and for the requirement where we are joining the streams, which is the business process monitoring, we have some business rules to join them, basically. So if these business rules happen, then we combine them in Flink and we write them to Elasticsearch in this case. But anyway, we can write again to Kafka, so some other team could, or to the Nakati event bus. So any other team could use this new event.
So if you're writing back to Kafka on each of your different deployments of different use cases, can you comment on how you manage the explosion of topics? You already had 1,000 events per topics, and I can only imagine the combinatorial use cases of my views. My BI use case is just going to go that.
Yeah, well, we haven't reached that point, actually, because we are just, as we said, we are moving from our data center, old monolithic architecture to microservices, and still we are moving there. So still, we have 1,000 topics, and with every requirement, we create probably 1 or 2 new topics, but still we haven't found this problem with having a lot of thousands and thousands of topics yet. So still our Kafka appliance, it's working very nice. Yeah.
So do you have any use case for managing the back pressure?
Flink manages back pressure by default.
Oh, do you mean the use case? I introduced the use case from Zalando Lounge. Yeah, as I said, there are several ad campaigns running, and then the customers can buy fashion items at a discount. And they have a specific time interval when they are able to buy those products, and also the quantities are limited. So it's in their best interest that they buy at an earlier date. So we expect in time interval of 1 hour that our order placed goes 10 times, for instance, or probably more. Yeah.
Yep.
Do you have use case where you are training separate Flink jobs and use Kafka as the means for doing that? And since Kafka doesn't provide consistency guarantees, you run into any problems with that with Kafka?
I didn't understand. Can you repeat, please?
So you have scenarios where you kind of chain multiple Flink jobs. So the output of one is going into a Kafka topic, and that becomes input for the next one. But since Kafka itself doesn't provide complete consistency, you run into any issues with those kind of scenarios?
Well, so far, we don't have any chain jobs yet, because all the things that we have done are much more or less independent. But when we will introduce the complex library, the complex event process library, then for sure we will have to face that. But now, so far, we haven't found that. Yep.
So what's the biggest Flink-related difficulty you ran into?
Well, so far I would say scalability, because if you configure one job to run with, I don't know, 10 task slots, and then you, I don't know, you change, and the flow changes in, I don't know, 2 or 3 orders of magnitude, as, for example, in this launch case. So at 7 a.m. in the morning, instead of having, I don't know, 10 clients looking at the web page, we have 10,000, yes? So then the Flink job could be slower. We haven't found that yet, but it could be slower, and we cannot increase the number of task slots dynamically.
So auto-scaling is the buzzword you're looking for. And as far as I know, it's currently on the roadmap for Flink, but it's not there yet. So, yeah.
Our appliance scales, so we can add more worker nodes on demand. But if we are running one Flink job that consumes, I don't know, that uses 4 slots, we cannot increase the number of slots for that Flink job. So that would be.
What is your Kafka topic setup like? What is your number of partitions?
It depends. It depends. Now, we have topics that have 5 or 1 partition or 3 partitions, because it depends much less on the size of the topic. Yes? On the size of the information. Because now, as I said, we are moving back, we are moving to Amazon, we are moving everything. So a lot of things are still happening in the data center. So all the new services that we are implementing are still rolling up in Amazon. And we haven't found any problem yet with this configuration of 5 partitions or 1 partition. But so far, it escalates properly. We haven't faced any issue with that. Okay.
Any other questions? No? Then
Great. Thank you.
Thank you for your attendance.